This chapter, wireless network troubleshooting and optimization, I think is kind of a review of a number of things that we've talked about. So hopefully it's a refresher on many of those things. Describe the steps in troubleshooting RF interference. And the steps in troubleshooting RF interference, what are you going to do? What do you need to know in order to troubleshoot RF interference? What the interference is. And what do you need to do that? That's where the spectrum analyzer comes in. When you do that walk around, I really want you to turn on the microwave in the break area so that you can see what happens. I think it's pretty amazing. And then you know why people say that the wireless goes down at lunchtime every day, or at dinner time if it's a night shift or breaks or whatever else. There is, as long as it's plugged in, and I'll check it when you do that to be sure you have. I put one other interfering source in the building so that you can see that and see if you can find it. So you can see what those look like. And once you find it, I'll tell you what it is. The techniques for troubleshooting a WLAN configuration. Configuring these things, how many do you need? And this, a lot of it goes back to the site survey. What kind of coverage you're actually getting? What kind of interferences are there? What are the data rates that you get? And once you do the planning, you do the predictive, you really got to put these things in, physically install them, and then see what you got. What's the signal strength? And can you connect to it? And if you can connect to it, can you actually do anything on it? What do people need to do? Do they need to upload, download files, or do they just need to get to the internet? Internet traffic really isn't that demanding unless you're doing something like downloading a file, downloading a video, watching a movie or something like that. Those can be, although if you look at those packets tend to be not all that big in many cases. Voice over, we talked a lot about voice over IP, and it is a big deal. Delay and jitter, and yeah, that's a big deal. But if you look at the voice packets, they're tiny. They're measured in Ks, not Ms. They're in kbytes, not megabytes, but kilobytes. So there's a lot of them, but they're relatively small in nature. But that's one that you really don't want to mess up because that's, you get yelled at, and I probably told you this before, but when they first put in the email server here, it crashed like 2 days later. And the network administrator at the time at Virginia Beach said, you know, we got this thing that we didn't have 2 weeks ago, and now it goes down and it's a crisis. Same thing's going to happen with your phones. If they're not working right, it's going to be a crisis. And a lot of times, go back to the reboot. Scott Meredith, that they have that problem at Korea, and they start getting echo, and the answer to fixing the echo is reboot the router. And that gets everything synchronized again. And reboot does a lot of things for it. Printers won't fix all the problems, but one of the best ways to fix a lot of printer problems is to turn it off, turn it back on. It clears all the memory, gets a restart. Same thing with computers a lot. Sometimes is it just being stupid. Turn it off, turn it back on. Yeah, that's no fun, but that will do some of those things. Steps in troubleshooting wireless devices. There are steps in that. Describe how to optimize a WLAN. I think the way to optimize a WLAN is to keep everybody else off, isn't it? Only you are on it, then it's optimized. And it's a 40 megahertz bandwidth at 600 megahertz or 600 megabytes per second. That's my idea of optimizing it. Sources can be grouped into 3 categories: RF, WLAN configuration settings, and problems related to the wireless device itself. Is the device working? Is it working properly? And these things, I think, and you guys may tell me differently, but they tend to last a long time. They tend to be pretty consistent. And I think for the price, and I keep going back to the price, because they don't cost that much in the big picture of things, the scheme of things. Because if you go into, even one of these switches back here in this room are going to be a couple $100. Now that one that where they ask you to, you do the report on pricing, they got the pricing thing in there, an $899 wireless access point, maybe not. You got to be realistic when you do that. I don't know who decided on the default price on that, but wireless device, and you guys did the comparison, most of them were not really all that expensive, and they had a lot of features on them. The end devices are all the home end devices, and those are 300 megabits per second, right? I think most of them are now. Are generally under $100. $69, $99, $89, $79. I haven't seen anything under $69, I don't think, but for the, and that's a quantum leap. We're going from 54 to 300 meg. And when you do, if you play with the different devices in that predictive site survey, see what changes with the range. I mean, in this one, if you do the one without walls and you put in that really high-powered end device, it covers the whole building and half the parking lot. But what are you going to do with those things? Well, the problems are related to the devices. RF interference is one of the main sources. And when you do this, look at and they're going to have a picture of it, look at the noise level. What kind of noise level do we have in here? And I think that it's really not all that bad. What are the interfering sources? And one of the things that I think I want to do, if they'll let me in there, this room over here, 106, which is now a storage room, I had a student one time said, can't connect in that room for whatever reason, and there may be a reason, because there's some antennas just outside it. That's where that theater is over there, and then what they do, and that comes and goes. So is there RF interference in there? I don't know the answer, but should be able to find that with a spectrum analyzer. And that's where that comes in, the RF interference. What are the issues? Are there issues with RF interference? And it has to be on the frequency that you're using, because if somebody's blasting away with an AM radio in the kilohertz and you're working in the megahertz, probably not going to be a real issue with you. What frequencies? And the 2.4 gigahertz has just tons of stuff that can interfere with it. Like my headset, which is still buzzing to me. But microwaves, the wireless controllers, the access points themselves, if they're overlapping, and the going back to the multi-channel or the single-channel architecture, the single-channel architecture depends upon the fact that the signal will be a signal and noise will be a noise. Noise is going to be a much lower level, so that you can put them all on the same channel. External interference and intersymbol interference. Remember the intersymbol interference term? Intersymbol interference is what happened when we had multipath and they got there at different times, and they tried to interpret both of them, and then you got overlap. And that's something that probably could cause the echo in the phone if you got the same piece of data at different times and you try to read them both and you try to get that message at the same time. External interference, EMI, electromagnetic interference, lots of different things that can do that. Fluorescent lights are one of the things that can affect those things. Electric motors, multiple things. And I probably told you I had a student one time who said, my wireless isn't working real well. Well, where's your access point? Oh, it's sitting on my refrigerator under a fluorescent light. And literally that's where it was. You want to try to move it, and it's not, then I have to go make a piece of cable or an extension cord or something. But where do you want these things to be? And when you look around when you're putting them in, where do they go? I don't have mine personally I don't use wireless that much at home, but I don't have it in the ideal circumstance because I have it exactly where they say that people do it at home. It's in a closet. And it's in a closet on one side of the house, which means that on the back side of the house, am I going to get the best coverage? I get enough coverage that it's okay. It's on the second floor, and I have a basement. Where should it be ideally? On the middle floor. That's where, James, that's what yours is, right? And I told you about the first one that I put in. They wanted it in a bedroom over the garage, and then we couldn't get a signal in the basement. Well, golly, I had to go through the kitchen, through all those cabinets and the dishes and the refrigerator and the dishwasher, and 2 sets of hardwood floors in order to get to the basement. And then whatever walls were intervening, and I don't remember that. So, yeah, in hindsight, is it any surprise that that didn't work? Where are you going to locate these things? And then where are you going to locate them is going to be one of the determining factors of how many do you actually need and how much coverage do you need. If you want to get coverage to every single corner of your building, you're probably going to need more, because omnidirectional or directional antennas, I guess we should quantify that. Omnidirectional antennas are going to basically be in a circle. And if you look at the real polar plots, they're not exactly a circle, but they're pretty close to that. And then all the predictive software draws them that way. RFI, so EMI, electromagnetic, is something that's caused by the electrical equipment. Motors, compressors, and the refrigerator compressor is going to have some of those emissions. RFI are radio frequencies. Those are the ones that are going to come out of the antennas, something that we're going to do out of an antenna of some sort. And what about these little access points that many of you are carrying around right now in your pockets? Can they cause interference? Yeah, they might. I think that they're probably not all that high power. I don't know. I haven't used one. I don't know what kind of power comes out the antenna, but based on running it off the battery, probably not as much as comes out of an access point. So what are they? And that goes back to, you can detect those with the software. The difference between the software and a spectrum analyzer, the software only detects things that are configured to be access points or two computers connecting with each other. You can see those things. You're not going to see just the spurious RF transmissions. You won't see, when you're walking around with the Wi-Fi detector, you're not going to see the microwave oven. You may see your connection drop, but you're not going to see the emissions from that. That's, again, where the spectrum analyzer comes in. The noise is just unwanted RF signals, and you're going to have a noise floor. The noise floor is just what's there. When you use a spectrum analyzer, it's going to give you the maximum signal that you got at those frequencies, the current, as well as the average, and the average is going to be what our noise floor is going to be. How much is there in general? The noise floor here, minus 130 dB. That's not bad, is it? Minus 130. What is, and if you go back, think back, help a little bit maybe, the signals that they use as the minimum signals in the predictive site survey, depending on whether you wanted what you wanted, but the lowest one was minus 73 dB. So minus 73 dB on this would give you 30 dB of difference, which should be plenty to overcome that. Minus 70 is the one that I think generally people use, and minus 67 for the voice. James?
Oh, I was looking at that. That's a 60 difference.
Yeah, and that should be, yeah, I said 30, didn't I? That would be minus 100. But minus 70, minus 60 dB, that's almost as much as the signal that we're talking about having. So that should be plenty to overcome this floor. I think when you do the one that in here, you're going to find that the floor is a little bit higher than that. Not a lot higher, but a little bit higher. The different kinds of 4 categories: narrowband, wideband, all-band, and weather sort of interference. And we talked about narrowband and wideband early on in the frequencies, what we can have. Wideband is over a wideband, and that's what we're using with 802.11, isn't it? Wideband, and frequency hopping particularly was a wideband. Narrowband is a very narrow part of the spectrum itself. All-band, microwaves maybe, all band, when you look at that, it goes all over creation. And then weather, a lot of that is the atmospherics, how much moisture is in the air, what's the cloud cover, fog, those kinds of things will affect you. Depending on the frequency, thunderstorms, lightning can affect you. And lightning can affect you if it hits something, obviously, near your antenna. So narrowband, usually generated by television, radio, satellite transmissions, small bandwidth in the spectrum itself. Troubleshoot, use a spectrum analyzer to determine the effect on the WLAN channel. And the spectrum analyzers, and again, if you get one that goes to a very wide spectrum, they're going to be really expensive. And the number that I've seen popularly quoted is $10,000 to $14,000. If you only want to get one that does the frequencies that you're interested in for wireless, the 2.4 and the 5 gigahertz spectrum, those are considerably less, under $200. So if you're going to do this for a living, you really do need that. What sources do you have? What frequencies are? Because if it's narrowband, it may be only on one channel. It may be on channel 6, for instance. Then you can use 1 or 11. You don't just stay away from the noise if you can identify it. If you can identify the source, that's even better. Do away with the source of the noise. This is the narrowband. It builds up there, and you can see that it's high. Golly, I picked channel 6, and it's the channel 6 interference. What can we do there? 1 and 11 look much better, although it's building up around there. That kind of a narrowband is spreading out a little bit. But you should be able to see those. Wideband affects the entire band of frequencies. That would be from channel 1 through 14, even though we don't use all of those. Or they're used in other countries. Locate the source of the interfering signal, and wideband things, I mean, honestly, things like microwave ovens will do that to you, or somebody's actually trying to jam your signal, because what's a great way to do a denial of service attack on a wireless? Noise, radio interference. What's the noise source? And we can sometimes do these to ourselves. In the real old days, when we actually had TV antennas that you had to receive your signal for, and you had 3 stations. And 2 of them didn't work. Actually, where I was from, when we finally got TV, we had 2 stations. But we could always tell when a Ford drove by.
A what?
A Ford.
Wow.
Because of the frequency, it was the points. Would interfere, was at that frequency, would interfere with the VHF. These were VHF stations with the VHF. How long was ago with this? This was in the late 50s and early 60s.
Oh, wow. I can only imagine.
Yeah. Huh? I don't know about anything later, because once you go, it doesn't matter on cable, does it? Although, what about sunspots? What about sunspots? Do they interfere with us? Satellite communications. Is it narrowband or broadband? That's kind of, it can interfere with, it's an all band, right? So sunspots are and that's not anything that's not something we can do anything about. And that's we'll go to something that we really don't want to go to, but using nuclear weapons in space, what does it do? It just wipes out all of your communications channels, because it interferes with the atmosphere so much. Atmospheric interferences can affect those things too. So there are a number of ways to do that.
Didn't they actually set off a nuclear warhead in that atmosphere?
Oh, sure. You can set it off any place that you want.
In the 1970s, they did that, and then some place could be.
Well, in the 1970s, when we were actually doing atmospheric testing, there's a lot of things that we probably shouldn't have done, because they learned a lot, but it did a lot.
The radiation stayed there for like 10 years.
Yeah, Bikini Atoll. And golly, guess where the swimsuit name came from? That's where they did a lot of atmospheric testing, was in Bikini Atoll in the South Pacific.
That's really where they got the name Bikini?
Yep, that's really where they got the name Bikini.
Well, I'd like to know where they got the name Spankies from, because that's horrible.
I don't know.
The little underwears that they
Oh,
wear.
that I have no clue. That I have no clue. We're going to go away from that and back to this. Frequency hopping spread spectrum is the one that uses narrow portions of a broader band to do individual transmissions, so that it theoretically is not going to be affected as much by interference. And that's one of the reasons that the military used it for a number of years, because it was going around, and you would only get maybe, hopefully at least, get interferences on narrow bits of the data. It also was a method to do that was a method to try to avoid signal jamming of the communications channels. Change solutions, all band interference. Change the spectrum, modify the power levels, add switching software, change the MAC layer, change the physical layer, so different ways to do that. Modify the power levels, and that's one of the things, if you find that you're interfering with yourself, how you can do that, you can turn down the power level. If you turn down the power level, you may actually increase your throughput by doing that. You're going to have to, in order to actually change the power level, you've got to have an access point that allows that to happen. Weather interference, refraction, we talked about refraction early on, and that's affected by how much moisture is in the atmosphere. And I think that it refracts away, and that can actually change satellite signals too. I think most of what happens on that is really the absorption from the moisture. At that frequency, moisture really affects those things. One medium to another, such as cold, damp air to warm, moist air. Boy, that cold or damp air, warm and moist air, can affect the signal, can cause the signal to bend in one way or the other. But when we start talking about damp and moisture, we're really talking about some absorption here too, because the frequencies that we're talking about, moisture, water, really absorbs a lot of that signal. For those of you who have satellite TV, me included, heavy thunderstorm, it goes away. Sometimes even heavy cloud cover, it'll go away, depending on how, and you can only see what you've got. You have to look at one of the radars. How high does it go? How much moisture is there? And that could be refraction or it could be absorption. I think most of it really is absorption. RF interference troubleshooting, be wary of the noise and recognize the situation. Maintain a system operating margin. Remember, the system operating margin is how much signal you have above the noise levels that you have. And what we're really talking about here is interference, is general interference in a particular area. The power levels separate the antennas as much as possible if we're interfering with ourselves. But the system operating margin, enough power in order to do those things. Intersymbol interference, the copies are added together. The intersymbol interference is multipath, the different bits of the data getting there at different times. And multipath is something that fiber uses in order to put a lot of different signals on it, because the different colors, the different frequencies are going to get there at different times. And that's something that happens with that as well as with RF. Adding the signals to the primary signal, downfade, corruption, nulling, or upfade. Remember, if they're exactly correct, if they're exactly 360 degrees out of phase, then they're going to be additive. If they're 180 degrees out of phase, that's where you want to get the nulling, so that the pluses and the minuses get there at the same time and we have no signal. In the meantime, we may have signal degradation, downfade. You may have corruption of the data itself. Supports MIMO. Use the correct antenna. The Yagis, the more focused antennas, directional, semi-directional antennas are going to prevent a lot of that, because you can get the signal going the way that you want without as much interference maybe. Co-channel, adjacent channel interference, power setting system throughput, the WLAN configuration. Co-channel is all the APs set to the same channel, throughput would be reduced. So we got to look at, are we configuring ourselves to do interference? Co-channel exists with no free channels available, 1, 6, and 11. And one of the ways to make that better is go to the A band, because there are more channels there. We didn't build, the builders built all these channels, but they're only 5 megahertz, whereas the transmission needs 22 megahertz. So that's why we only have the three clear channels. And you got to look around in your neighborhood, and you hope that people are smart enough to know 1, 6, and 11. I think 6 is probably the default. That's probably why, if you look around, you'll see an awful lot of them on 6. I looked around my neighborhood, and the ones that I can intercept in the house are all at the lower end, so I put mine at 11 to try to avoid that. And I don't think I ever really had, because their signals, I have a signal operating margin that's sufficient on all the other ones because it doesn't really take, you don't really have to get that far away. If you're in an apartment building, it might be a different situation, but if you're in a house, unless they're relatively close together, you may not have those kinds of issues. Adjacent, when one transmission on one channel encroaches on another channel, if I've got 1 and 4, for instance, we're going to have adjacent channel interference. Incorrect power settings. If you can manage the power setting high, low, you can bring the power level to a level so that the channels aren't interfering and still hopefully get your coverage, because if you're doing that, and you may need to have the number of access points to get to the extremities of the place that you're trying to do things with. Spectrum analyzer again, and this is the, do we have the correct power settings? The smartphone, the 40 milliwatts, the 100 milliwatts, doesn't kind of matter here, does it? Because the 40 milliwatt one's going to get back, regardless of what we do with it. But we're going to improve it. Actually, we brought the smartphone in closer to bring it inside the coverage area, narrowed the beam, and up the power to 200 milliwatts. But if we do a 200 milliwatt access point and we have a 40 milliwatt sending device, that may or may not do us any good. They can see you, but they can't connect. And that's one of the things that with the bring your own device world, all of those are, everything's not going to be broadcasting with the same power. What you're going to have to do is determine what's the lowest power device you got and set your coverage up so that if you want everything to connect, set it up so that those things can connect with you, because just because you can get there doesn't mean that they can get back to you. The WLAN transmission speed, the processor speed, distance from the AP, all of those things can affect it. The packet size, the distance from the access point, and the hidden node sort of phenomenon, can it see it, are things that can affect those things. Throughput problems, the RTS, request to send, clear to send. Point coordination functions in the upgraded access points are really what you want, and if it then starts detecting collisions, we're going to go to the RTS, CTS, request to send, clear to send, which is going to slow things down. Because before you send any transmission, you got to get permission from the access point. So instead of using all that timing mechanism that we looked at, you ask the access point, it says go ahead, and the advantage to that in the hidden node area, if it's hidden from, it's going to be hidden from a station. It's not hidden from the access point. So when it sends the clear to send, the other stations know to stay off of the frequency until the timer is timed out. What's experiencing problems? And this is the standard troubleshooting procedure. And if even in a wired network, what's the first thing you want to know? Is it one machine or is it all of them? If it's one machine, odds are it's at the machine. If it's all of them, odds are it's at the whatever our single point of failure devices are. It could be a switch, could be a router, could be a route, could be a routing protocol, all those different things when you get into. But what is it? The same thing here. Is it a single device or is it all the devices? And in this one, is it a single area or is it in all of the areas? Is it room 106 and is it just room 106? If that's the case, is there some RFI over there? Is the signal not getting there? What's causing those problems? And in this building, depending on the location of the access point, is it room 96 and 97 or is it the whole building? And if it's room 96 and 97, I think I know the answer. It's the cement wall between the rest of the building and it. That is a physical firewall in there. Incorrect or incompatible access point settings with other devices. When these devices come online, they're not going to connect to the access point unless it supports all of the frequencies that the AP does. So you may have to watch out for those things. So there are things that we can do. Does it support the security? If you've got a B card and you set up your G as a as a G only, then the B devices aren't going to be able to connect. So I can't connect to I brought my laptop in and I can't connect to the wireless. Well, you may have to go back and look and see what kind of cards they have. Hopefully nobody's going to be bringing B devices around. They haven't been sold for a long time. But the early B and the later B even had different configurations. Back to the proprietaries. Early on, we had proprietary access points, proprietary cards, and they wouldn't work together. That's where the Wi-Fi organization really did help things. The SSIDs don't match, the security settings don't match, a number of different things don't match. And the SSID, if you think about SSID, think about that as is in VLANs, because that's what we're really hopefully doing here is SSIDs are VLANs. And if your VLAN doesn't match, then you're not going to be able to conduct even on a wired network. Security settings don't match, you're not going to be able to connect on a wired network. We found that out with the 802.1x, right? If the security stuff didn't match, it doesn't work. And you saw that a little bit in routers when we did the VPN, or actually in the security class when we did the VPN, the router VPN. If the security parameters didn't match, then you don't make the connection. Same thing here, and that's probably easier to see in wireless because we talk about those things. Troubleshooting, device location, connectivity issues. Device location, I think we'll probably have beaten to death. Where should they be? Once you put them in, check to be sure that the predictive actually predicted well and that you really had the site survey right. When they did, and I don't remember if I said this, if I did, excuse me for repeating myself, but when they did the site survey here, they asked for a layout of the building, and they sent them the layout of the building, and they called up and said, what kind of walls you got? That was the site survey. And then they used the same software that I've asked you guys to get the account for, the Arrowhive, and did the predictive site survey, came and put the access points in. They seem to have pretty good coverage. I haven't gone around to every corner to see if they really do. There are some of them it looks like they might not, just based on the where I think they are and where the really tough to penetrate walls are. Near-far transmission problem involving two wireless devices. The device closest to the AP transmits a higher power and the other overwhelmingly weaker signal of the distant one because it's going to see the distant signal if it's too high as a noise signal, and it will ignore that. Move the devices around, and this is the picture of that. We got 100 megawatt on one. The closer one's doing 100 megawatt, and the further one is a 10 megawatt. The 10 megawatt may not be seen because of the 100 megawatt device. The hidden nodes. One station, the access point sees the stations, but the stations don't see each other, and that's when you get into the request to send and clear to send environment because it can't see the one station transmitting and can cause collisions. Connectivity, scan for wireless networks, choose an access point based upon the capabilities. What we're normally going to pick them based upon is the signal strength, isn't it? The RSSI. And whether it's protected or unprotected, and if it's protected, do you have the password to get onto it? Authentication, and that's one of the big deals, big issues about getting onto these things. Do people have the right password? And then how are we going to get the IP address? Manual address, DHCP address. Keep in mind, you can control, depending on how you configure the access point, whether you turn on DHCP or don't turn on DHCP. Actually, if it's just an access point, and if you look at those access points back there, you don't see a WAN port on them. The difference between an access point and a router, the access point literally extends your wired network to your wireless. So it gets plugged into the wired switch, and when you get onto it, you get an IP address based upon the area that you're in. If you connect those and connect to them through a wireless, you're going to get a 1062.11 address as long as it's connected to these switches. If you connect it to the WAN port on a router, then it's going to want a separate IP address inside the wireless than the device it connects to, and it's going to do a port address translation in order to do that. If you want your wireless router to be an access point, instead of plugging it into the WAN port, plug it into the switch port and turn off the DHCP server. Then you'll get IP addresses on that network, whatever they happen to be. We've done that a couple of times around here to connect, for the instance, the station up front in that's out away from everything that the receptionist is at. It's tough to get a wire in there. I think they finally did, but after, especially, you should put it in before they put the carpet down, right? Didn't do that, I think. So they hooked it up as a wireless, but we wanted it not to be routed from a 192 or whatever network, wanted it to be on that network. In order to do that, make it a switch. And then when that computer gets onto the wireless, it's on that network. You got to be careful when you do that, because now then if you have no authentication, no security on it, whoever drives by, since that's a window up there, whoever drives by and connects is now on your admin network, and that's where the management of these things comes in. What are you going to do with them? What are you not going to do with them? A PIPA addressing means it is not finding a wireless, just like a PIPA. It's not finding a DHCP server, just like a PIPA means when you're doing a wired network. The Windows stuff that you did early on, provide the wireless connection status, overview of the current status, display the layer 3 connectivity status, and they've done I think a significantly better job in Windows 7 to look at that and to get connected to wireless networks than they did in XP. And it's a whole lot better than it was in Windows 2000, because you had to go through a number of steps there. These basically say, do you want to go? Okay, and it'll go through all the connection steps for you. You guys have used that and you've done that, you know those things. Networking tab, sharing tab, I think you did activities to look at that when you went through those things. The Windows 8, simpler operating system, more integrated radio. If you want to check that out, this machine up here in the front has Windows 8. You'll have to restart it and pick Windows 8, but it has the Windows 8 beta on it. You can look at it and see if it does those things. I haven't upgraded it to the production model yet. Possible causes, the 802.11 standards. G's not going to connect to an N's backward compatible with everything, but let's go B's and G's, because when you get those, you have compatibility mode, which allows both B's and G's. If you make it a G only, then the B's can't connect. And you probably want to, because remember that if you get the B connected to your G network, it's going to slow things down. Mismatch keys, mismatch authentication methods, all the security stuff. Incorrect MAC address, and that is if we have done MAC filtering. You can do that if you want to prevent those things. But hopefully after you look at those packets, could you find a MAC address if you say, oh, this guy's got MAC filtering? Could you find a MAC address by going into monitor mode and watching the packets and seeing what machines are connecting to this thing? And the monitor mode's the key here, because you got to be in monitor mode to see all of that information that's on the access point that you're not connected to. So you could find a MAC address, and wireless is really easy. Actually, it's relatively easy anyway. There's lots of softwares out there that allows you to change the MAC address of your machine, so you can do that anyway. Disable wireless adapter, and you might laugh at that. I've seen that happen. Somebody put it into their case while it's in save state or something like that. Save state, wrong term, right? Not hibernated, but sleep state. That's where I wanted to go. And the switch, depending on the little switches, gets pushed, turns the radio off, and turn it back on, and oh, my wireless isn't working. Now they have these lights. They always had the lights, but people didn't look at them. We had an instructor do that one time. My wireless doesn't work, so I think the radio's off. Where's the switch to turn it on? I don't know. Oh, I certainly didn't know because this was before they made those things really, really clear. Now they're pretty clear about where the switches are on them. But finally found the radio switch, turned the radio switch on, and it works. That happens. Those kinds of things happen. A legacy wireless NIC driver, oh yeah. Outdated profiles, all of those things can affect you. Disabled adapter. I mean, the things that you would not expect is the radio turned on and you get the, what's the radio? But you have to look for those things. Hopefully it's going to have a light that tells you, you know, white is on, red is off, or green it's on and red it's off kind of thing. The troubleshooting steps, incompatible 802.1x authentication. What I have found, having done that lab many times, the issue is generally going to be certificates. You got to have a certificate on the supplicant that, well, actually, you got to have a trusted authentication authority on the supplicant that trusts the authenticating server. And what we do, you got to put it on because we issue our own certificates, and you're probably going to issue your own certificates in an enterprise environment because those things cost like $100 a piece, and if you've got 1,000 computers, that's going to be pretty expensive. So if you issue your own, you got to be sure that the supplicant machines have the server that issued the certificates have in the computer, not in the user, but in the computer, recognize that as a trusted third party, and you can add those yourself. Channel access point, wireless device optimization, all of those things. The channel for roaming is a primary concern, and roaming, remember, allows you to go from one access point to the other without losing your connectivity. To do that, you're going to have the same SSID, probably different channels and the same security on the access points. Once you do that, you should be able to roam, and you need the channel overlap so that you have the, and their recommendation, I think in the last one, was a 10 dB overlap, so that you can have a smooth transition, especially if you're doing voice over Wi-Fi. Coverage area from one AP to the other, if the SSID and the security settings are the same, and the cell overlap we need to have. Might be clustered, such as a lecture hall, auditorium, on-school campus, apartment building. Optimize the channel by installing a high-density wireless LANs. And the high-density ones, remember if we looked at the ones we had, the one, that was Arrowhive, I think, that had the 12 access points incorporated in a single device, and we could use the different channels going in different directions so that they didn't interfere with each other. And those things, when we talk about those kinds of devices are not going to be inexpensive. Never accept the default configuration, and that's easy to walk around and see who has, right? We have all these cool names like Linksys and D-Link and Netgear. If they haven't changed that, did they change the security on the admin and blank or admin and admin or whatever the default passwords are? Yeah, maybe not. Huh? Probably not. So you want to change those things, and I think that really you probably want to change the default subnets also. I mean, not just from an interference standpoint, but those are known subnets. 192.168.0. .0 network is, I think that's D-Link. 192.168.1 I think is Netgear, and then Linksys, I think Linksys probably uses .1 too, I don't know. But that just gives somebody one step closer. Somebody if they're really trying to get on your network, gets them one step closer to what's going on. So put your own subnets in there, and that way if you do that, you can actually tell if you're on your own network if you have these high density things. Captive portal, you guys did that one, and Pico cells means that we're just reducing the power so that we're not sending it to everybody. And the apartment building, Might be a place where you want to reduce the power if you don't want everybody trying to get onto your wireless. Also, don't use the defaults and have your security configured. Those kinds of things. The coverage sizes based on the power levels, and this picture's in the book. I know it's hard to see on the presentation, but what do we get? How far can we go? And the further you get away from the access point, the lower the data rate's going to be. I think they show 450 feet for the 11B and 325 feet for the A. The 11B goes down to 1 megabit per second, and the A goes to 6 megabits per second. Those are the standard data rates that those guys are going to support. Voice, and I guess we've touched on voice a lot. If you're going to do voice, you need better coverage. You need good overlap for roaming so that you don't get the drop calls. And it's set for aggressive roaming if those access points have those kinds of configurations. If not, you're just going to have to go see what the signal strength is and get the overlaps at and minus 67 dB is the voice standard for the overlap, and bring it back 10 dB. Bring it back in 10 dB. Again, this one is kind of, I think, an overview. These are things that were covered in all the different chapters. It's kind of, instead of setting it up, well, what can happen? Well, what can happen is the same thing that they said in the chapter. You get the channel interference, you get noise. People don't know what the security is. They change the security, those kinds of things. And you guys never have trouble connecting to wireless, right? Anywhere.
3 concrete walls that next to these box, no wireless don't work.
3 concrete wall, yeah. And that's what they always say, that you may want to use in older buildings where you have trouble drilling through the walls and things like that, right? What we're going to do, then we're going to have to run something up on the roof, and then we can set up bridges to connect those networks together. Something like that might work. Oh yeah, there's lots of that in those buildings. Questions, I told you today wouldn't be a real long one, because this is a hopefully a rehash of things that you've already done. A lot of these activities you have already done. Questions? Going once, going twice. Okay. Take a break, and then hands.